Granny, how big is the universe?
Well, darling, the universe is really, really big. And it's still growing, just like you.
Is it? So it was once as small as I am.
It was even smaller than you are. It was even smaller than the little nail on your toe. It was even smaller than a proton.
Proton. That's small.
That's really small.
Can I grow as big as the universe?
Well, darling, if you eat all your veggies during dinner, then you might just not maybe reach it. You never know. You should keep on trying though.
Granny, can you tell me a story about the baby universe?
Of course I can, honey.
Well, a long, long time ago, in a kingdom called the false vacuum, there was nothing at all. But if we look really, really close, we suddenly see this small wrinkly baby universe. The single point contained all the matter of the universe and had an incredibly high density and temperature. The naughty baby didn't listen to any of the laws of physics and called himself the Big Bang.
Tch, what a show off!
I know, girl. And then, immediately, 10 to the minus 36 seconds after the Big Bang, because it ate all of his veggies and because the negative pressure of the false vacuum yielded an anti-gravity, this little baby universe grew at a fast speed, faster than the speed of light. And which is very naughty again, because nowadays nothing is allowed to go faster than the speed of light. And this event is called cosmic inflation.
Huh? But how do these people know this?
Well, if it wasn't the case, our universe would have been full of magnetic monopoles, which are magnets but with only one pole, and their gravitational effect would have caused baby universe to collapse immediately after its birth.
Oh, murders!
Luckily though, this is obviously not the case, honey, because we still live here, and inflation swept most of the monopoles out of the observable universe. Also, it stretched the universe to be perfectly flat and ironed out any irregularities. This is why the universe today is completely flat and looks the same in all directions. Inflation also explains why cosmic microwave background, also known as the CMB, that's the thermal radiation that is left over from the Big Bang, is distributed equally all over space-time.
And that, Sophie, was the story of inflation. And now it's time to go to bed, honey.
No, Granny! Where do all the animals come from? Where do their mummies come from?
Well, so that's a good question, honey. But it will take another story to tell because we have to go back 500 million years in time.
Before this time, no big and complex animal fossils that are related to animals today, like dogs and cats, were found. But there were some simple animals that became extinct, such as the Dickinsonia and the Kimberella. However, the Cambrian explosion changed everything. This was not literally an explosion, but a fast expansion of animal species that took 15 million years. And during this time period, evolution accelerated, which resulted in a huge increase of diversity. The oceans became a paradise with fascinating organisms, such as the Anomalocaris and the Opabinia. The cause of the Cambrian explosion remains unclear. Weird enough, there were also smart people who calculated that we should find the uncles of our dogs and cats in much older rocks. They studied this with DNA clocks. The people that look in the earth and the people that use clocks to calculate when those old animals first set foot on our earth still have discussions about this and are looking for evidence in favor of their own.
But what is DNA then?
Well, honey, I will tell you about DNA, but that will then be your last story of today and then we'll really go to bed, okay?
Yeah, Granny.
Okay, well, I'll take you to the world of the DNA fun.
Okay, well, I'll tell you about our knowledge of DNA and how this knowledge has grown over the years. So you see, girls just like you are made out of cells, and each cell contains DNA. DNA contains the genetic material in our cells. you could see it as a person's manual. A book inside every cell that tells, for example, whether you have brown or blue eyes, and many other things. And at first, people didn't know what this book looked like, and in what language or in what way it was written. But about 60 years ago, when I was just a little older than you, two fine gentlemen discovered that this book looks like this. Two strands wrapped around each other in a double helix. And the complete information in our cells is covered in 23 pairs of these strands.
So each has 23 books inside it?
Well, not really books, of course, but these very small strands, and they are called chromosomes. And these chromosomes don't contain letters and words, but building blocks, called nucleotides. And there are 4 kinds of building blocks. And as you can see, they are matched so that there are 2 matching pairs that fit perfectly together. You could compare these building blocks with the letters in books. And if you combine 3 of these building blocks, they code for an amino acid, a word in our book. And if you make a sentence out of these words, so combine several amino acids, you create a protein. And proteins make sure we function the way we do. So imagine how our knowledge expanded. We went from knowing nothing about DNA to knowing all of this. But then people became curious and decided to translate all the 23 chromosome pairs in a human cell. They wondered what these manuals would say about a person. And this project of mapping all the nucleotides is called the Human Genome Project.
And that was the last story of today. Go. Now, tight in bed and have a good night's sleep.